Hi everyone. Today I'm going to be giving a little bit of an introduction to deep learning. Now, imagine with me for a second. How does your phone unlock just by looking at your face? Or how can AI create voices that sound human or generate art that looks like it came from a painter's brush? The secret is deep learning, and that is the powerhouse behind today's biggest breakthroughs in artificial intelligence. It's the reason AI feels so real or so human-like. Now, what is deep learning? At its core, deep learning is a type of machine learning inspired by the human brain. Our brain has billions of neurons connected in complex networks, and deep learning copies this idea with artificial neural networks. When you feed these networks data, whether it's images, speech, or text, the information passes through each layer of interconnected neurons. Each layer learns something simple, just a tiny piece of the puzzle. But as the layers stack up, the network begins to understand highly complex patterns. And that's how computers learn to recognize your face in a photo, translate language, or even write a song. Now, why is it called deep? The deep in deep learning refers to the depth of layers in the network. A shallow network might only have one or two layers, but a deep network can have dozens, hundreds, or even thousands of layers. And each layer builds on the last. So the first layers, in this example, this is an example of a CNN, which is heavily used in applications of computer vision. The first layers of a neural network might detect simple things like edges or colors in an image. The middle layers combine those into shapes and patterns. And the final layers recognize the whole object. For example, this is a dog or this is a cat. And this hierarchy from simple details to abstract concepts is what gives deep learning its incredible power. So, what are the breakthroughs that made deep learning possible? Deep learning isn't actually brand new. The idea has been around since the 1980s. So why did it suddenly explode in the last decade? Three key breakthroughs unlocked its potential, and that is big data, GPUs, and smarter algorithms. Now, with regards to big data, there are billions of images, videos, and text samples that have become available thanks to the internet. Neural networks need huge amounts of data to learn, and now they have that. With graphics processing units or GPUs, originally made for gaming, turned out to be perfect for the intense math deep learning requires. Suddenly, training massive networks has become more practical. And lastly, for smarter algorithms, techniques like backpropagation allowed networks to fine-tune themselves by adjusting the strength of their connections, a bit like how humans learn from mistakes. Now, deep learning is heavily woven into everyday life, whether that's in healthcare, self-driving cars, voice assistants, finance, entertainment, large language models today. For example, in healthcare, you will see that algorithms are capable of reading x-rays, detect cancers, and even predict disease risks earlier than doctors sometimes even can. With self-driving cars, deep learning helps cars detect pedestrians, road signs, and traffic lights in real time. With voice assistants, of course, most people would have used Siri or Alexa or Google Assistant, and that all heavily relies on deep learning to understand and respond to your voice. Now, with regards to things like finance and entertainment, finance or banks use it to detect fraud by spotting unusual spending patterns, and with entertainment, recommendation systems and Essentially, Netflix uses AI generated or deep learning in order to recommend different art, music, and of course, with large language models, tools like ChatGPT, or even what you're listening to now, are powered by deep learning at an unimaginable scale. So, what is the magic or behind all of this, and how does it actually learn? So, the simplified version of how deep learning works is that each neuron takes in numbers, performs some math, and passes a result forward. The network makes a guess, say this picture is a dog. If it's wrong, the system corrects its guess to the correct answer and learns by adjusting tiny weights in the connections. And over thousands, even millions of training cycles, the network becomes astonishingly accurate. It's a lot like practicing a sport, or if you've seen a baby human try to learn something for the first time. The first time you may make some mistakes, but with feedback or back propagation, to use the correct term for deep learning or neural networks, and repetition, you improve until one day you perform with the highest precision. But here's an important reality check. There are challenges and limitations to deep learning. It needs enormous amounts of data, something humans don't necessarily need. It's also often a black box, so we can't always explain why it makes a decision. It can also make silly mistakes, like confusing a school bus for an ostrich if the pixels look similar. And it reflects biases present in the data it was trained on. So while deep learning feels intelligent, it doesn't actually understand the world. It's still just spotting patterns, just on a massive scale. Deep learning has transformed how machines see, hear, and think. It's why AI today feels so powerful compared to 10 years ago. But remember, this isn't human consciousness. It's advanced pattern recognition, guided by data and math. So the big question isn't only what can deep learning do? It's also how will we choose to use it? From medicine to art, from business to education. The choices we make will shape whether deep learning becomes a tool that empowers humanity or one that divides it. If you found this video helpful, please make sure to leave a like, comment, and subscribe. Thank you so much.